I'd recommend pausing right here and trying to see if you can make this map into a graph. And when you're ready, then watch the video. Alright, so if you're unpausing, we need a vertex A. I'm just trying to follow the placement of the regions over here. B, C, D, E, and F, and then G would be the facial region of the fish, and then I for the eye, I guess. That's kind of convenient. And then H. Alright, so it looks like A is touching B, B is touching C, so all of these kind of are connected like that, and then they all also are adjacent to G because they share a side, so all of these come to G. And then again, G is also adjacent to I and H, so that would be what that map looks like as a graph. And then very similar to what we did earlier, we could start with A and make it red, and then skip B, and then C is red, skip D, and then E is red. And we can't make G red because it's adjacent to A, C, and E, but we could make I and H red because they're not adjacent. So if you look, no two reds are adjacent to one another. Then you could come back in with blue and make B blue. D I could also make blue because it's not adjacent with B. And F I could make blue, but I could not make G blue, so G needs to be its own color so you can make it green. So you can see here the chromatic number had to be 3 for that graph, which is identical to that map technically. Alright, the next one is it says determine the chromatic number of each of the following graphs. Alright, so let's try that technique. Alright, so A will make red. We cannot make B red because they're adjacent. C we could make red because it's not adjacent to A. D again we can't make adjacent because it touches both A and C. E could be red though. And then F cannot be red because F is adjacent to E. So then we come through and make, let's see, try B. B is blue. We don't need to do C. D we can make blue because it's not adjacent to B. And F is adjacent to both blue and red, so we'll need to make it its own color. So the chromatic number of this graph done in this way, we use 3 colors. So the chromatic number is 3. Again, great place to pause and try these on your own if you like. Alright, so A, I could make red. Can't make B red because it's adjacent to B, nor can I make C red, but D could be red. And then let's see, E cannot because they're adjacent. F could be red though because it's not adjacent to either one. And G cannot be red because now every single thing at least somewhere is adjacent to a red, so we'll go back and use blue now. So B could be blue. C could be blue, not adjacent, but neither E or G can be blue now because they're all adjacent to that. Alright, so let's use green for E. E could be green, and since it's not adjacent, G could be green. So in this case I was only able to use, I only had to use 3 colors again. Alright, this last one, really kind of interesting. It's a K5. You remember how we have a K5 if A is adjacent to everything, B is adjacent to everything, C is adjacent. So if I make A red, nothing else can be red because it's adjacent to everything. If I make B blue, same problem. Nothing else can be blue because it's adjacent to everything. If I make C green, again, it's adjacent to everything, so I can't use green again. So if I make D purple, again, not adjacent to everything. And if I go to F or E and make it a different color, I actually have to use 5 different colors. Now I said we didn't need more than 4 colors for a map, but this is not a map, this is a graph. It basically means there's no way you could redraw this as a map in 2D. It takes something more to actually recreate this in terms of a map, but graphs can be as many color chromatic numbers as you need. So the chromatic number of this graph is 5, and there's no way this could ever be a planar graph, or planar map, sorry, a planar graph or map, because you could never, it should only use 4 colors if it's a planar map. I hope that was helpful to at least see how many colors you needed. I'm going to stop here and I'll start the next video in just a moment.